Let's practice finding the probability of different outcomes from two-way tables. Marginal probabilities is where we're going to start, and this is probably the easiest one that you can do. We're going to start out with some notation. Now, probability of some event, so probability that something is going to happen, is we mark that by saying P of that thing. So P of that event, or that P of A, or whatever we're trying to find the probability of, we'll wrap it with P in parentheses. So for example, P of dog here means that we want to know the probability of getting a dog. And in this table, the probability of getting a dog means we don't care about specifically one color, two color, 3+ color dogs. So we don't need to look at those details. We only need to look at the total over here, the margin. So there are 120 dogs, it says. There are 232 animals. So that means our probability of getting a dog is just going to be 120 out of 232. And for this, I'm not going to have you reduce or convert to a decimal or a fraction. You could do that, but I find that it's easier to catch mistakes or figure out what you did wrong when you keep it as a non-reduced fraction. So I'm going to have you do that. Probability of two colors. Now, two colors, there are 78 animals that are of two colors. It doesn't say anything about it being a dog or a cat. And it's out of 232 total. So here we would do 78 out of 232. In most cases with these problems, your fractions, your probabilities are always going to be out of that total in the corner. So the 232 in this case. Now, and we'll get to problems where that's different. These are examples of those weird exceptions to the rules. Conditional probabilities. The probability of some event given some condition. And usually when we work with these, I think the easiest way to work with them is to work backwards, to take your condition and deal with that first. Then it's a lot easier to figure out the probability of whatever you're trying to find. For example, this one reads the probability of a cat given that it is one color. So when it is given that it is one color, I find that it's easier to start there and get rid of all the things I'm not interested in. I don't care about 2-color cats or 3-color cats or cats of all numbers of colors. It has to be exactly one color, which means that I'm only going to be looking at this column right here. Now, what's the probability of finding a cat? Well, now it's an easy problem. There's 53 cats out of 128 total. The reason that I like to cross it out is because the problem becomes very obvious when you do that. Otherwise, you might get confused with this total down here, this 232. Same logic applies to this next one, probability of finding a cat given 2 colors. So given that there are 2 colors, we only look at this part of the table. Now, probability of a cat, 45 out of 78. So 45 out of 78. And this last one here flips that around. Probability of 2 colors given a cat. You might think, same thing, no big deal. But if we take our time, work through it, we see given that it's a cat, our condition here, given that it's a cat, means we're only going to look at cats. And when we only look at the cats, we're going to have a different total. So now the probability of finding something of 2 colors is 45, just like before, 45 out of 112 now. We have a different total it's out of because we're given that it's a cat. 45 out of 112. So this answer is going to be different. Let's look at intersections where you have two things both happening at the same time. Two different events at the same time. So probability of getting a cat and getting one color. Well, here's our cats. Here's our one color. They intersect right here. There are 53 cats of one color out of 232 animals. So now we're back to our big total. We're not trying to take any conditions anymore. So back to our big total. 53 out of 232. Next one here, we have probability of a dog and 2 colors. So dogs, 2 colors. There are 33 dogs of 2 colors. There are a total of 232 animals. 33 out of 232. And then the last one here, 2 colors and cat. We have cats, 2 colors, 45 out of, again, a big total, 232. 45 out of 232. Or, which is mathematically called a union many times, is the probability of A or B or both. Now, some of you may have seen the Venn diagram before. It's where you have these 2 intersecting circles. One represents A, one represents B. In the middle is both. So A and B. Now, when we did the A and B before, it only included this part where they both intersected. But when we do OR, it includes the only A, the only B, and the middle region, the overlap. So don't think it's just one or the other. It does include the overlap. So finding the probability of a cat or 1 color. One way I like to do this is to go through and say, where are all my cats? Well, here I have a cat, 53 cats of 1 color. I have 45 cats of 2 colors. And I have 14 cats of 3 or more colors. Then let's find all my 1 color things. I have 75 dogs of 1 color and 53 cats of 1 color. Circle that again. Well, there we have it. We have all the cats and all the 1 color things. So if you are one or the other, or both, you will get counted. So you just add these numbers, 75 plus 53 plus 45 plus 14, and you would get 187. And that 187 would be out of the big total. There's no condition, so it would be out of the 232. If you're looking for a quicker way to do that, in this case, we already have these totaled up here, 112. So I could just take this 112 plus this extra 75 here and get 187. Or if you're looking for something that scales to much bigger tables, you might notice that we can take the total here, 128, and the total here, 112, and if you add them together, you get 240. You would get 240 if you added those 2 numbers together. The reason that this number is too big is because we double counted these 1 color cats. You're only supposed to count them once, you're not supposed to count them twice. So if you subtract 53 out of this, you're going to find that you get 187, our correct answer. So if you take these 2 totals here for the row and the column, you add them together and you subtract that thing that you overlapped, you counted twice, then you're going to get exactly what you're supposed to. So let's practice that again. Dog or 2 colors. And I like to use a highlighter when doing these because I can do it real quickly. Dogs. There's all my dogs. My 2 colors are right here. And I don't want to include the margins. I'm not counting the things in the margins, so I can erase that just to make sure that we don't get that confused. Don't need my labels anymore. So all the numbers I highlighted we need to count. The quickest way to do that is just to add these 4, or in this case we can take a little shortcut. We can add that 120 over here to this extra little 45 hanging off the side to get 165 out of our big total 232. The last thing, 2 colors or cat. So we have cats. Here's our cats, our 2 color animals. We add those numbers together, and if you do that in your header in your calculator, you are going to get 145 out of 232. Now mixing them up. What do we do when we get something complicated like this? One or two colors given that it's a dog. Step one, you have to deal with that condition, that given. So let's only look at dogs. Everything else, totally irrelevant. Scribble it out. Now, the probability of one color or two colors. So we have to include both of those options. And it's going to be out of what's left in our table. We only have 120 left in our table. So this condition is what makes it only a one-row table. And this one or two means I have to circle two different things and add them together. So if I add those numbers together, I'm going to get 108. And that 108 is going to be out of 120, because that's our total number of dogs. So that's a complicated one. Something a little simpler here, probability of cat. Well, 112 cats, 232 total, 112 out of 232. Two colors and dog. Well, and means it has to be both. So we have two colors, we have dogs, so our two color dogs are 33 out of our big total, no conditions, so 232. And last one here, probability of being a dog given that you have 3 plus colors would be first figuring out 3 plus colors, 3 or more colors. Now probability of being a dog is going to be 12 out of 26 because we ignore the rest of the table. So 12 out of 26. And that is finding probabilities.